Hey, Precalculus, it's Coach Jay. Hope you're doing well. We are going to review 3.5 and 3.6 today, and we're going to hop right into some questions that need to be addressed and just some review questions off that as well. So we're going to hop right into it so that we don't waste your time. Hopefully you see the behind me will be the schedule on the board as well as on campus. So if you have any questions on that, feel free to access that at any time there, okay? We'll go from there. As far as some of these questions go, I want to make sure that we do hit on a couple. The ones that you see in red right here, number 10, and I'll kind of go through them. There's 3 of them. This one right here and this one right here at number 24. Those 3 are going to be important. You are required to finish those 3. And I'll kind of go back here. So if you want to take a screenshot of it, kind of hold it there, even pause this video. These 3 are the ones that I want you to do and turn into me by the end of the class period. And I'll even give you a full homework grade on that so we can kind of boost our homework average there. All I want to do is just make sure that you kind of get it and do it. So even as I go through it, if you already understand it, get those 3 done. We'll finish and go from there, all right? Sweet. Okay, so with this one, number 9, says an initial investment is $750. Now, we know that that is our P, right? So we know it's 1 plus R over N to the NT power, and that equals A, right? That should be over on the side, on my left side, on my right side, your left side in the classroom. So you should have those there. As far as the R goes, we don't know exactly what the R is, but what we do know is we're trying to figure that out, trying to solve it, right? So we're trying to find what R is, and it's compounded continuously. Now, normally, if we have it in terms of like compounded daily or yearly, this is the formula we would use. But in the essence where we're trying to solve for compounded continuously, we're going to actually use the formula that is A equals PE to the RT, where, again, P is 750, and we have E, base E. We don't know what the R is. And it does tell us that in this example, the time that it will double is 7 3/4 years. So that's interesting, because if it's doubling, right, we know that the amount, or A, would be 1,500, because double of 750 is 1,500. So we have E to the R times, and T would be 7.75 years, or 7 3/4. All right. So now the goal is to solve for what the R is, and we can do that very similar to what we did on block day and Tuesday by dividing by 750. And when I do that, I get 2 is equal to E to the R times 7.75 power. Now, once I do this, I can get rid of that E by taking the ln of both sides. And once I do that, I get canceled out on this right side, okay? To where then the ln of 2, okay, kind of come back here, doing this on my calculator, ln of 2, and then I'm going to divide that by 7.75, and when I do that, I get R is equal to approximately 0.0894, or we say 8.94%. So that would be our rate in regards to our annual interest rate there. Now, as far as the amount after 10 years, what we can do is find, we can use that same percent, 8.94. So we're going to kind of clear this. And so we're trying to find the A now. A is equal to 750. E to the R, well, that's 0.0893 times 10, which is the amount of years, 10. We're trying to find what A is, right? So we can do this now by plugging this in. So we'll do E to the power of, do base E to the power of 0.0893 times 10. And then I'm going to multiply that by 750 total to get 18. So we have, after 10 years, I have $1,831.83. And so that right there would be my amount that I would have at the end of 10 years, okay? All right, you again will do number 10, so feel free to do that as you continue. Now, in class, we should have gone through one of these. Just a heads up on that. If you were to kind of go through that there, you're going to go to kind of your stat and you're going to kind of go to your list there where the X's would be L1, and then the Y's would be L2, right? And then kind of go at it from that side. And then you're going to go into kind of stat plot, which is if you go to second Y equals and kind of go towards that, you'll start realizing that, kind of what we're talking about on that side. You want to make sure that the second one, which is like your scatter plot, is kind of tweaked there. And you want to make sure that the X is the list is L1 and Y is L2. And once you do that, once you end up graphing that, should be good. You should be able to see kind of a scatter plot to where you could see which is the best fit. Again, we did that on block day, but just a heads up on kind of how to do that there. If we need to come back to that, we can on that one. All right. All right, the next one we're going to hit on, we kind of hit on one of those in class as well. Again, we could go over that again, kind of have your initial, right? And then you plug the kind of what the half-life is and go from there. We've looked at that on block day. If we needed to look at another one on that, we could do it during class, all right? So let me do one of these, and let me come back to the stat plot, and we'll do that once I pull up this calculator that's there, okay? All right, so on this one, again, is a little strange. What we know is that the formula for kind of our exponential here is, so we have our y is equal to ae to the x power, right? It's kind of what we know. Xt or bx power. Hold on just a second. I'm going to make sure I delete this here. Okay. Sorry about that. Hold on just a second. All right. Sorry about that. So we're coming back. And so what we have now, and I'm making sure that calculator's up. Perfect. So it's actually a b to the x power. Now remember that the a is the number in front, whereas b is the number that's kind of with x here. All right. So what we're trying to do is find out what a and b are. But the problem is that we can't figure that out because in this instance, what we have is we've got two different points. We have 0, 1, and 3, 10. So we're going to plug 3 in for x. So we have a b to the 3 power, and that equals 10 because 10 is y, okay? So we've got that there. All right, so that's number one. The second one is 0, 1, so we're going to plug 0 in for x. So we have, and then 1 in for y. So we have 1 equals a b to the 0 power, okay? Now what's cool about this is that we could kind of figure this out and kind of solve for it, right? We're trying to solve for the equation. So b to the 0 power, anything to the 0 power is 1. 1 times a is a, so a is equal to 1. Well, we can then plug that back in for a to where we get 10 is equal to 1 times b to the third. Well, what we have now is 10 equals b to the third power, right? B to the third. And so what we can do now is off of this is we could kind of take the third root of this to kind of get a decimal for what b is. So we could take the third root, or we could take, if you're like confused on that, what you could do is just say, all right, what is 10? Let me do the third root. Sorry, this will cancel that out. So the third root is 10 to the 1 divided by 3 power. Okay, to get 2.154. All right, so b is 2.154. 2.154. And so what we have now is a is 1, b is this. So we have y is equal to 1 times 2.154 to the x power. And that right there would give us what our equation is. Now let's say that it wasn't that easy. What you could actually do is once I plug this in, you'll notice that it kind of works out the same way, similar way here with number 24 to find exactly what our equation is. So you're going to try to use number 24 to find what that one is. So go ahead and kind of model that the same way. Now, as far as 29 goes, very similar to what we did in terms of on block day, where we have our kind of our bacteria after a certain amount of time. The K is, we don't know what the K is, right? But what they're going to do is we're going to try to figure out if T is 5, we're going to try to estimate the required population that will double, like time that will double in size, okay? So again, if we know N is 300 when T is 5, right? So we'll kind of start that off for you. So we'll have 300 equals 100 e to the K 5, because 5 is T, right? We can find what K is. Once I find what K is, I can plug it into a new equation, right? To see when is it going to double in size. So double would be 200, right? Equals 100 e to the kt power. What we would look for here is the T once I find what K is from this point, all right? So you're going to find what K is, plug it in, and again, 29 is what you would use for that, all right? Hey, let's do this. Again, I was holding off on this just so that you can kind of see it. Now let's use this equation, the linear regression here, make sure that we kind of understand what's going on this. So let's pull up the calculator here. I'm going to put this down. And we're going to pull up a new one, okay? That way you can see it. I want to make sure I at least hit one of these here. Okay, so let's say that you were to do one of these linear regressions, and we'll say that we're doing, we'll actually do one off the homework. Hold on just a sec. Let me get one off the homework. Okay, so let's do number, it says 9, 16, and 18. So let's do number like 16, okay? Is that cool? Actually, let's do, I'm trying to see which one would be better. Trying to see if we can. Sorry, y'all. Hold on just a second. Okay, yeah, let's do this. And the only reason why I wanted to show this to you, so if you go to stat and go to calculate, when you go to, it's an exponential regression. So we'll do like number 16 here. So what you're looking at is when you go to exponential regression, you're going to do that where L1 is the X list and L2 is the Y list, okay? So just a heads up there. So we're going to go to second. It's a little different than what my last calculator was here. Let's go to, not second, I'm sorry. Let's go, yeah, second stat right here. You see that list, L-I-S-T? And if you press enter, you'll notice this is the L1, this is the X column, L2 is the Y column, okay? So what I'm gonna do is for 16, I'm gonna plug in all the X's. So 0, 2, 4, 6, 8, and 10, okay? And on the L2, we'll do all the Y's. So we'll do 6, 8.9, 20, 34.3, 61.1, and 120.5. Okay, so once I get to this point, it asks this. Well, we can also graph this, just so you know. If you were to graph it, you could go to second stat plot here, and you see right here how the stat plot is off. If you press down, or I'm sorry, just press enter there, and then go to on, press enter there on that side. If you were to graph this here, you'll be able to see, and it actually graphs both. We don't really want both, but if you go back, if you zoom out here, you'll be able to kind of see a little bit, kind of that linear regression, right? You see the exponential regression. With this cubic, we don't want the cubic in, but right now, we'll just leave it in there. Okay, so you again just go to second stat plot, make sure this is on. Once I press enter, I'll make sure that, again, it's kind of in that plot there, and we've got it. So, and once we press graph, you see it right there without the cubic on that side. So then if you go to stat here, go to calc, and then go to exponential regression. Remember, we put L1 in X, L2 in Y. If you press calculate, you'll see that the actual answer would be 5.54 times 1.36 to the X power, and that'll be Y equals that. So just a heads up on that. I want to make sure I put you through those there. Thank you all so much for your time, and I hope this was helpful for you. And see y'all Monday. I miss y'all. See ya. Bye.